Hey, this is Math 6, Unit 4, Lesson 12, called Fractional Lengths. Okay, and we're going to be talking about different ways to solve problems involving fractions. There's not really one set way of doing these problems here today, so if you have a different method that works for you, that's awesome. So we'll go through some different ways of doing these today. So here we go. First of all, we have a little number talk here to find the product mentally. So kind of thinking about how might you multiply those two numbers together, just doing some mental math, okay? Again, it just depends on what you see and how you might want to break those up a little bit. A couple things to think about is, you might think that this is about 20, right? That's about 20 right there. This one here, if you thought that that's 20, I could probably just mental math do 20 times 14, or 2 times 14, which is going to be 28, right? That's the 28 there, and then add the 0. So I'm knowing about 280 right there by doing 20 times 14. But I know that I've also gone, in a sense, too far because I should only do 19 of them. So if I thought about doing only 19 of them, I would subtract 14 from that and end up with 266. That's one way to do some mental math real quick, is just to kind of say, well, I know 20 times 14 is 280, take away one of the 14s, I'm down to 266, something like that. You could also have thought about 14 as being a combination of 10 and 4, and if you multiplied 19 times 10, you're at 190. And then if you did 4 times maybe 20, that gets you 80. And so again, then you're sitting about 270, but you did about 4 too many there. So you take away 4 and you're at 266. That to me is a little bit more complicated because there's a lot more steps here. This is how I kind of did it mentally. But again, it's just mental math and what you kind of see and what you notice. So there you go. Let's look at activity number 2, which is our real one for today. It says Jada was using square stickers with a side length of 3/4 inch to decorate the spine of a photo album. The spine is 10.5 inches long. If she laid the stickers side by side without gaps or overlaps, how many stickers did she use to cover the length of the spine? So we're thinking about something like this. There's a book, right, that has a spine of a book. That's like, the part that maybe has a name on it, history or whatever it might be. And the length of that spine is 10.5 inches long. We know she's going to put a sticker on it. Let's make a sticker right here, just make one, that happens to be 3/4 of an inch long. We're just wondering how many stickers does it take to cover the entire spine with no gaps and overlaps. Another way of thinking about this is I have 3/4 times some number of them is going to get me to 10.5. As a division problem, that becomes 10.5 divided by 3/4 equals what I'm looking for there. So there's two ways of setting this up, multiplication and then turning that into division. As a division problem, what I have is 10 times 2 is 20 or 21. Well, let's rewrite it here just so we can take a look at it nice and cleanly. So here's 10.5 divided by 3/4. This becomes 21 over 2 divided by 3/4. And we've talked about that when we divide by 3/4, that's the same as multiplying by the reciprocal. So we multiply by 4 over 3. We can reduce on the diagonals here. There's 1 3 there, and there's 7 3s there. We can reduce on this diagonal, and there's 1 2 here, and there are 2 2s there. 7 times 2 straight across is 14, and 1 times 1 is 1, so we just leave it there as 14. Okay? So that's the idea, right? We're seeing how many of these 3/4 inch stickers fill on that space there. Okay, for the next one, it says how many 5/8 inch binder clips laid side by side make a length of 11 1/4 inches. So again, it's like taking a look at like binder clips, maybe you want to call them paper clips, whatever, and taking a lot of paper clips here and then laying them down and wondering how many of those would it take to get a total length of 11 1/4 if every single one of them was 5/8 of an inch. As a multiplication problem, you might think this is really something like 5/8 times what number of them would be equal to 11 1/4, which would make a division problem of 11 1/4 divided by 5/8. And it's going to be what we're looking for here. So this becomes 4 times 11 is 44, plus 1 more is 45 over 4. That's how we turn the mixed number into an improper fraction. Instead of dividing by 5/8, we're going to multiply by the reciprocal, right? So we're going to flip that over there. Then we can look for how we can reduce. So I have 8 and a 4 here, and I know that there is 1 4 in there, and there are 2 4s in there. Here 5 and 45 go together with 5s. So we have 1 5 in here, and we have 9 5s here. Now multiplying across, 9 times 2 is 18, and 1 times 1 is 1, so we leave it as simply 18. So we get 18 5/8 inch binder clips all the way to fill up that space right there. My picture has 4, but again, that's just my picture to kind of help me see what I'm talking about. Okay, number 3. It takes exactly 26 paper clips laid end to end to make a length of 17 and 7/8 inches. Estimate the length of each paper clip. Okay, so we're going to take 26 of these guys, right? 26 of these things, and when you get 26, you'll get a total length of 17 and 7/8. Estimate the length of the paper clip means how long is one of them? Well, if I have 26 and I get a total length of 17, if each one happened to have been maybe 1 inch, right? Like up here, if it was 1 inch, then we would have a length of 26. So we know it has to be less than 1 inch for sure. Do I know exactly what it is there? Not based on my estimation, but that's just telling me my answer when I figured out in part B, calculate, should be something less than 1. I should get a fraction value less than 1. So again, what we're talking about here is we're saying that however long that paper clip is, if I have 26 of them, that's going to be a total length of 17 and 7/8. So to figure out what this is going to be, this question mark is going to be, I'm going to do 17, oops, sorry about that. I'm going to do 17 and 7/8, the length there, divided by 26, the number of paper clips I have, to find out how long each one is going to be. So this one's a little bit different here. I have to do 8 times 17 plus 7. And when I use a calculator for that one, I end up with 143, and the denominator stays the same, over 8. Now divided by 26 means to multiply by the reciprocal. And 26 is 26 over 1, so I write 1 over 26. Alright. Now, what's a little strange here is these are not maybe numbers that you recognize too well. I mean, they're not ones that I play with too much. So I know with 1 and 8, I don't see that really goes in common there. And so you can multiply it out, but what's a little odd is that 13 actually goes into both of these, which is just a strange number to use. Sorry about that, but 13 goes in here 2 times, and 13 goes in here 11 times. Okay, 13 times 2 is 26, and 13 times 11 is 143. Those are not numbers that I normally play with or know off the top of my head. I just figured it probably went with something, and in working out earlier, I was able to work backwards. But okay, just helping you out there. So multiplying across, 11 times 1 is 11, and then 8 times 2 is 16. Nothing else to reduce there. We have 11/16 inches is the length of the paper clip, which makes sense because we said it should be less than 1, and 11/16 is certainly less than 1 whole. All right. Okay. There's an activity here called Are You Ready for More, which sometimes we do, sometimes we skip, but let's just kind of talk through it real quick, all right? It says Lynn has work of art that is 14 inches by 20 inches. She wants to frame it with large paper clips laid end to end. Man, this must be a fantastic work of art if she's going to make a frame out of paper clips. So, she has paper clips, 14, well, she has a paper here, 14 by 20. Let's make this 20, let's call this 14, that's our work of art. And she's going to put paper clips around the whole thing like this, right? End to end on both sides of the artwork. Okay, now the paper clip, it says, is 1 3/4 inches long. How many paper clips would she need? Show your reasoning and be sure to think about potential gaps and overlaps. Consider making a sketch that shows how the paper clips could be arranged. So there's our cute little sketch there. Nothing too fantastic, all right? You could certainly take a lot more time with this to figure this one out, okay? But I'm going to do a little bit faster version, all right? So here we go. First of all, we know that there are 20 inches here, and a paper clip is 1 3/4 inches long, right? So to find out how many are going to be there, I'm going to do 20 divided by 1 3/4 of an inch to see how many paper clips can I get on this long side. In doing that, I know that I have 20 divided by, this is 4 times 1 is 4, plus 3 is 7. So 20 divided by 7/4. And then when I multiply by the reciprocal, we end up with 80 divided by 7, or 80 over 7. And 7 goes into here 11 times, and that's 77 with 3 7s remaining. So I know that I'm going to need 11 here, and it goes a little bit more than 11, right? So for that one, it's going to be a little bit bigger than that, okay? So in order to get that, I'm going to need 11 and more, which means I'm going to need 12 for sure, but I'm going to have a little bit of overlap, basically is what we're saying. So I know that I'm going to need 12 on one side, and if I put 12 on this side, I'm already up to 24. 12 and 12 is 24. So I'm going to estimate that to be 12 and multiply it by 2 because there's 2 sides, and now I'm at 24. Now when it talked about figure out potential gaps and overlaps, this is where it's like, well, what do they mean exactly here? You know, if I actually use this, I don't really want the paper clips to overlap, so if this one kind of stuck over the edge, then that would mean that this one wouldn't necessarily go as far. It's just hard to say. Either way, I'm just going to estimate it and say, let's go with 24 there. You could get more like detailed if you chose to, but let's just do that for now, okay? Now on the 24, yeah, no, sorry, yeah, you can do 24. Yeah, that's fine. You could also just do 11 times 2 and 22, so somewhere between 22 and 24 is good. On the other side, we would do 14 divided by 7/4, the same length, which is 14 times 4 over 7. Those would reduce, and we're left with 8. All right, so that's a little more clear there on that one. And because, again, so I get 8 there, 8 there, because there's 2 of them, we would say times 2 is 16. So I'm going to have 16 on one side, about 24 on the other, which is going to be about 40 paper clips. All right. If this one is a little bigger, you know, you could do it again. It could be 22. So you could say anywhere from 38 to 40 paper clips are probably going to work. If I really wanted to worry about the gaps and the overlaps, I could be more specific there. But just because this is just to see can you make it work, that's a good approximation there. And the next one, it asks how many paper clips are needed if the paper clips are spaced 1/4 of an inch apart, meaning you have a paper clip like this, but then you're going to leave a gap like that, right? Some kind of gap in between them. So then how many would you need? Okay, so when you do this here, you're creating extra space, which means that because of that 1/4 inch on each side of them, a paper clip's going to now be longer than 1 3/4 of an inch. All right, it's going to have an eighth of an inch gap on this side, and an eighth of a gap inch on this side. Why an eighth? Because an eighth is half of a fourth. So an eighth and an eighth is a fourth, right? That's 1/4 together. And when we add that to the 1 3/4, we know that the whole space here, from here to here, the gap space in the paper clip is actually equal to 2 inches, right? So you're going to definitely have fewer paper clips. We could say that for sure, because they're taking up more space with the gap, right? And how many? It'd be a little different. And when you describe the arrangement of the paper clips at the corners of the frame, again, that's for you to kind of think through what might that be. You know, what would it look like if this one came over and this one came over? You'd have to have a gap and a gap. You get the idea. How many would you use? Less than 38 to 40, but I'm not going to figure out exactly how many. It's somewhere in there. It's, again, a fun little problem to play with, but we have other things to do right now. So here we go. Activity 3. How many times as tall or as far? It says a second grade student is 4 feet tall. Her teacher is 5 2/3 feet tall. How many times as tall as a student is the teacher? How many times as tall is a student as the teacher? So what we're saying here is, in this case, look at my notes real quick. Yep. Right? How many times as tall is how many times as tall as the student is the teacher. So the student is 4, and we're going to say is the teacher 5 2/3. Now, this problem here, we want to turn into a division problem. So we're going to say 5 2/3 divided by 4 equals what we're trying to figure out. This becomes 5 times 3 is 15, plus 2 is 17, so we have 17 over 3. And we'll multiply it by the reciprocal of 4, 4 over 1, which is 1/4. And I don't see anything in common between a 4 and 17, or a 3 and a 1, or a vertical as well. So we're going to end up with 17 over 12, which as a mixed number becomes 1, because there's 1/12 in there, with 5 left over. Alright? Now when we ask ourselves, well, what fraction of the teacher's height is a student's height, that's a little different, right? Because now we're going to change the order of these things around, right? So what fraction of the teacher's height is a student's height means we're going to take the student and we're dividing the student's height by the teacher's height. So it's the opposite of what we did there. Think of it as a fraction, right? The student is a part of the teacher. It's a student divided by the teacher. So it's a student's height divided by the teacher's height. So in this case, it's 4 divided by 17 over 3, which becomes 4 times 3 over 17, which is 12 over 17. And we can leave it just like that. Notice that when I change the order of the division, and the order of the division here, what happens to my solution? I have 17 12ths there, and what do we have over here? 12 17ths. So you end up with, not the opposite, but it's like inverting those things there, okay, or the reciprocal in a sense. All right, let's move on. Number 2. Find the quotient, show your reasoning, check your answer. All right, so for this one, we could do it a couple ways. We could do 9 times 5 times 1/3. That would work. So 9 times 5 is 45, and times 1/3, or divided by 3, would be equal to 15. That works there. You could also have done 9 times 5 over 3, like so. Reduce that to 1, reduce that to 3, and 3 times 5 is 15. They both work. It's a matter of which method you prefer. For the next one, let's turn this into an improper first. 8 times 1 is 8, plus 7 is 15. So we have 15 over 8. And let's do multiply by the reciprocal, 4 over 3. So flipping that one over there, 4 over 3. Looking here in diagonals, I have 1 3 here, and there are 5 3s in there. 4 and 8 are in common by 4. They both have a 4 in them. There's 1 4 in there, and there's 2 4s there. So multiplying straight across, 5 times 1 is 5, and 2 times 1 is 2. So I end up with essentially, wait, something's off. Oh, 3, 5, yeah. So we have 2, 3, yep. Yep, 2 1/2. All right. Good deal. Let's look at number 3. Number 3, we're going to write a division expression to help us answer his question, and then if we get stuck, we can draw a diagram. It says a runner ran 1 4/5 miles on Monday and 6 3/10 on Tuesday. How many times her Monday's distance was her Tuesday's distance? How many times her Monday's distance was her Tuesday's distance? So how many times her Monday's distance, 1 4/5, was her Tuesday distance? See how we have there? How many times her Monday was her Tuesday? Now to make that a division problem, we can say 6 3/10 divided by, let's move that over there, divided by 1 4/5 equals question mark. So that's our actual problem. So let's write this up over here. We have 6 3/10 divided by 1 4/5. And put those into improper form. 10 times 6 is 60, plus 3 is 63 over 10. Keep the denominator the same. And then 5 times 1 is 5, plus 4 is 9. So this is divided by 9/5. All right, and then we're not going to keep it like that. Instead, we're going to multiply by the reciprocal. So we flip that one over there. I can look for something reduced. 5s are in here and here. There's 1 5 in there, and there are 2 5s here. For this one, I know that 9 is in both of them. How many 9s? There's 1 there, and 9 times 7 is 63. So I end up with 7 times 1 is 7, 2 times 1 is 2, So I have 7 over 2, which is the same as 3 and a half. So how many times her Monday's distance was Tuesday? 3 and a half. So if we took 3 and a half and multiplied it by 1 and 4/5, we would get 6 and 3/10 there. A cyclist planned to ride 9.5 miles, but only managed to travel 3 and 7/8. Man, what fraction of his planned trip did he travel? So because it's a fraction, we're basically doing the part of the trip divided by the whole trip is what we're asking here, just like in the prior question. So the part of the trip we did 3 and 7/8, we did that much, and we did that out of 9.5 is what we're trying to do. So we can rewrite this as improper. 8 times 3 is 24, plus 7 is 31 over 8, divided by 9 times 2 is 18, plus 1 is 19 over 2. We're going to rewrite the first one, and then we're going to multiply by the reciprocal of 19 over 2, which is 2 over 19. We know that 2 and 8, there's 1 2 in there, and there are 4 2's in there. 19 and 31 are just some funny numbers. We just leave them like they are, nothing we can do about them. So in the top numerator, we have 3 times 1 is 31, and 4 times 19, using a calculator, I got 76. And we leave it just like that. So what fraction of the trip did he finish? 31/76. Is that a nice number? Nope, it's just a number. So have a good day with a number. All right, activity 4. Here we have 3 short paper towel rolls and 1 long paper towel roll. We can see that the longer one is equivalent to more than 2 of the short ones, and the short one is less than, a whole one there. So the length of the paper towel roll, this roll, is about how much times the length of the short paper towel roll? Well, this is about half of it, right? Half of that one. So we would say this one is equivalent to 1, 2 and a half. So 2 and a half times. Now I could write 2 and a half like 2 and a half, but notice this. This is 2 times 2 is 4, plus 1 is 5. So it's 5 over 2. That's the length of that one. When it asks me the length of the short paper towel roll, as how many times the length of the long paper towel roll, I can actually say that it is 2/5. Just like one of our prior problems. If I take the reciprocal, it tells me the other distance, right? So how long is this compared to that? It's 2/5 of that length. And why 2/5? Well, if we break this up into fifths here, right, we can see that if this is broken up into fifths, like that, that the paper towel is equal to the short one, is 2/5 of the whole thing. Does that make sense there? My pencil's coming through very well, right? So we take our long tube and divide it into fifths. I can see a little better. Good deal. And when we do that, we can see that this is 2 of the 5 it needs to make the whole thing. Okay? So for our lengths here, we have 5 over 2 and 2 over 5. Let's use that for the next part. The next question says, if the length of the paper towel roll is 11 1/4 inches, what is the length of each short paper towel roll? Use the information you have about the paper rolls to write multiplication equation or division equation for the question. Note that 11 1/4 is 45 over 4, because 4 times 11 is 44, plus 1 is 45. So we're going to take the length of the paper towel roll, 11 1/4, and we're dividing it by 5 over 2, okay, for the short ones. Why? Because the short one is 5/2 of that. So this becomes 45 over 4 multiplied by the reciprocal, 2/5. We can reduce here. There's 1 5 in there, and there are 9 5's in there. We can reduce here. We have 1 2 in here. We have 2 2's in there. 9 times 1 is 9. 2 times 1 is 2. So we have 9 1/2, which is the same as 4 1/2. All right. So if the paper towel long one is 11 1/4 inches, then the short guy is 4 1/2 inches. And you think about it, does that make sense? We're saying that a short one plus a short one plus half of a short one is equal to 11 1/4? Well, this is 4 1/2 and 4 1/2, so that's 8, and that becomes 9, right? Then I have half of 4 1/2. Well, half of 4 is 2, and half of a half is a quarter. 9 plus 2 is 11 and a quarter, and we're back to where we started. All right, so that works out pretty well right there. Okay, so for your summary, idea here is that division can help us solve comparison problems in which we find out how many times as large or as small one number is compared to another. And they give you an example here of comparing a first song and a second song. The first one's shorter than the second one, and you can ask different types of comparison questions if you wanted to in order to see how they compare. You can ask things like, how many times as long as the first song is a second, right? So how many times as long is the first one, and that's our first number, is the second, is the equal, and that's our second song. Or we could say, what fraction of the second song is the first song? So what fraction is question mark of the second song is equal the first song? And we can see how that plays out right there. Then you rearrange it, make a division problem, and you're good to go using your algorithm to figure things out, just like that. All right, so I hope that helps you out a little bit. We're going to take a moment to work on homework, and we'll come back and check it together in just a moment. All right, homework time. 1 inch is around 2 and 11/20 centimeters. All right, so 1 inch is about 2 and 11/20 centimeters. Somewhere around there, right? That's our 1 inch. So how many centimeters long is 3 inches? Well, we know that 1 centimeter, or 1 inch, is 2 and 11/20 centimeters, and we're asking how many 3 are. So basically we're multiplying by 3. So 20 times 2 is 40, plus 11 is 51. So we have 51 over 20 times 3. Now, we don't have to flip anything, we're just multiplying. So it just is that simple. 51 times 3 is 153, and 20 times 1 is still 20. So 20 goes into 153 7 times, 140, right? And we have 13 left over with the denominator staying the same. So what fraction of an inch is 1 centimeter? So as a question, this becomes, what fraction of an inch? Well, how much is the inch? The inch was 2 and 11/20 is 1 centimeter. So what fraction of the inch is 1 centimeter? Or, as a division problem, this becomes 1 divided by 2 and 11/20 equals question mark. So I again have 1 divided by 2 and 11/20 is still 51 over 20, and I multiply by the reciprocal, 20 over 51, and we have 20 51st, like that. All right. This one says, what question can be answered by finding 10 divided by 2 and 11/20? Well, this is not that different from this one, right? This tells me what fraction of 1 inch, right, are in there. This one would tell me how many inches are in 10 centimeters. Okay, this is how many inches are in 1 centimeter. This is how many inches are in 10 centimeters there. Or what fraction of an inch is 10 centimeters. So use your words and write something down there. Number 2. Here we go. Comparisons. A zookeeper is 6 1/4 feet tall. A young giraffe in his care is 9 3/8 feet tall. How many times as tall as a zookeeper is the giraffe? So, how many times as tall is the zookeeper? As a zookeeper is the giraffe. How many times as tall as the zookeeper is the giraffe? Or as a division problem, we would do 9 3/8 divided by 6 1/4. So 9 3/8 rewritten becomes 72 plus 3 is 75. over 8 divided by 4 times 6 is 24, plus 1 is 25 over 4. And so that becomes 75 over 8 times 4 over 25. We can reduce here. That becomes a 1, that becomes a 2. We can reduce here, 125 and 3 25s. So we end up with 3 over 2, or 1.5. Now, if you think back to our notes, what we did in our lesson today, what fraction of the giraffe's height is the zookeeper's height? So we're talking about the zookeeper, 6 1/4 divided by the giraffe, 9 3/8. Now, you can certainly go ahead and do this, but if you look at your notes, you may already know what the answer is going to be, because the answer tends to be the reciprocal of this one, because we're dividing them the other way in a sense. So this becomes 25 over 4 divided by 75 over 8. We take the second one and multiply by the reciprocal, and when we reduce, we end up reducing the same thing. This is 1, and this is 3, and this is 2, and this is 1, and you end up with 2/3. So notice, we just have the reciprocal answers here when we divide in the opposite direction. We'll flip the numbers around. Okay, let's look at number 3. So the rectangular bathroom floor is covered with square tiles that are 1.5 feet by 1.5 feet. The length of the floor is 10.5 feet, and the width is 6.5. So length and width. How many tiles does it take to cover the length of the floor? So that's asking here. We're going to do 10.5, and we're going to divide that by the tile, which is 1.5. Okay. Over here, we're doing the width. Same idea. So we'll do the width, which is 6.5, divided by the tile. Now tell me how many tiles fit inside of there. So each of these is telling me that we're asking how many 1.5 foot tiles can I fit inside a 10.5. How many 1.5 foot tiles can I fit inside a 6.5 width? Okay, so the setup here is 20 plus 1 is 21 over 2, divided by 1.5 is 3 over 2. Over here, it's 6 times 2 is 12, plus 1 is 13 over 2, divided by 3 over 2. Right, and that's your setup. So that becomes 21 over 2 times the reciprocal. And the 2's are going to cancel. 3 goes in here 7 times, and we have 7 as an answer. And then over here, we're going to do the same thing. 13 over 2 times reciprocal, 2 over 3. 2's cancel. 13 and 3 have nothing in common, so we just end up with 13 over 3. 3 goes into 13 4 times. 3 times 4 is 12. 13 minus 12 is 1 left over, and the denominator stays the same. So we can get 7 for the length and 4 1/3 for the width. All right. Okay, let's take a look at number 4. Got a few more to go here today. Says that the Food and Drug Administration, FDA, recommends a certain amount of nutrient intake per day called the daily value. Food labels usually show percentages of the daily values for several different nutrients, calcium, iron, vitamins, etc. In 3/4 cup of oatmeal, there is 1/10 of the recommended daily value of iron. What fraction of the daily recommended value of iron is in 1 cup of oatmeal? Okay. So 1 cup of oatmeal. So 3/4 of a cup, we're saying here 3/4 of a cup. 3/4 of what is 1/10, right? So we're looking for the what is in the 1 cup. So 3/4 of what amount is going to be 1/10 from what we know. 3/4 of the oatmeal is in 1/10. So this becomes 3/4 times something equals 1/10, or as a division problem, it is 1/10 divided by 3/4 equals, I don't know. So we will do 1/10 times the reciprocal. Right, 2 goes in here 2 times, 2 goes in here 5 times, and we end up with 2/15. All right, so that's going to tell us what fraction of the daily recommended value of iron is in 1 cup. It's 2/15 of the iron you need for the day is in there. And that's what you get. All right, number 5. What fraction of half is 1/3. Okay. Draw a tape diagram to represent and answer the question. Use graph paper if needed. Okay, so what we're saying, what fraction of a half is a third? Okay, so what fraction of a half is a third? To solve this, we're doing 1/3 divided by a half, which is 1/3 times the reciprocal, which is going to be equal to 2/3. Okay, so as a fraction problem, as a tape diagram, you can draw that out there if you want to. Again, this is going to be looking at something like this. Here's one whole. We're looking at a 1/3, so that's our 1/3 right here. Right, and we're asking how many halves are in 1/3. Well, the half is right there. That's our half. So if we actually cut each of these into segments like this, and we end up with 1/6 type of thing, we could say that there is going to be, in this case here, that's a half, we end up with 1, 2 out of the needed 3, right? So we have that much, and when I need 3, so I hit 2 out of 3. Alright, number 6. Noah says there are 2.5 groups of 4/5 in 2. Do you agree with his statement? So he's saying that there are 2.5 groups of 4/5 in 2. So that means if we're taking 2 and we're dividing it by 4/5, we end up with 2.5 because there's 4/5 groups of 4/5. How many groups of 4/5 are in 2? He says 2.5. So let's take a look here. Let's do a group of 2 like this. There's 2. We're working with fifths. Let's divide it into fifths. 1, 2, 3, 4. 1, 2, 3, 4. And we're going to see how many 4/5 are inside of there. Well, 4/5 are going to be here. Here is 1, 2, 3, 4. There's one group of 4/5. Then I go here. Let's see. 1, 2, 3, 4. There's another group of 4/5. So that's 2. Right. So I'm up to 1, up to 2. And now what do I have left? Well, I have 1, 2 left. I have 2 little blocks left, and it takes 4 to make a whole. So I have 2 2/4, or really what I have is 2.5, because that's reduces to a half, and that's what I got. So is he correct there? Yep, he is correct. Great job. All right, that's it for the day. Hope you have a great day, and we will see you next time.